here we can see there are two types of switching topologies, like there is a dielectric isolation and in non-isolation. In our syllabus, we have to study about only dielectric isolation, in which we can see here it is based on small changes in the voltage gain, and we know voltage gain is nothing but it is the ratio of output voltage with respect to the input voltage. So it will be based on only that ratio. It means what? If we are having the output voltage that will be in higher amount as compared to the input voltage, or it will be in the less amount as compared to the input voltage, or it will have the opposite polarity with respect to the input voltage. On these things we can see here there are the three types of non-isolation voltage regulator. These are nothing but step up voltage regulator, step down voltage regulator, step up, step down voltage regulator. So these are some example. If you see step up voltage regulator, it means what? If output voltage in larger amount as compared to the input voltage, it means what? It will raise the input voltage, it will give us higher amount of input voltage at the output. And if we are decreasing the output input voltage at the output, at that time we can say that voltage regulator as a step down voltage regulator, because it will decrease the amount of voltage at the output, or we can say it is as a buck voltage regulator. If you see again, we can say there is a step up and step down buck boost voltage regulator. It means what? It can raise the level of input voltage, or it can decrease the amount of input voltage, or sometimes it will give us opposite polarity of the input voltage. So we can say like it is the step up step down voltage regulator, or we can say it is a boost buck voltage regulator. Again, if you see there is another type of non-isolated isolation switching regulator, like there is a charge pump voltage regulator. It will give us larger multiple amount of input without using the inductor, because we can see here we are saying these are step up step down. It means what? There is a concept of transformer, step down transformer, step up, and as there is a transformer, there is use of inductor. At that time only we will get the magnetic field, and at that time only we will get the output voltage that will be in higher proportion, or it will be in lower proportion with respect to the input voltage. So we can say it is as a charge pump voltage regulator, which will not use the inductor and which will give us multiple amount of input at the output. This type of switching voltage regulator we can say as a charge pump voltage regulator. And in dielectric isolations, it will be based on the radiation and the intense environment, but it is not in our syllabus. So if you see, there are some disadvantages and the advantages of the switching voltage regulator. And as no, we are using here switch, it will use rapid as compared to the linear voltage regulator. And here, instead of transistor, instead of diode, voltage divider circuit, we are using only switch to get the constant output voltage. So we can say the main advantages of the switching voltage regulator is it is more efficient, it is smaller in size, and it is having low weight as compared to the linear voltage regulator. But it is also more complex design, which is capable to handle the higher amount of power at the output. So we can say it will give us higher power efficiency at the output constant voltage. And switching voltage regulator can give us output voltage that can be greater than or less than, or that can be in the inverse polarity with respect to the input voltage. These are some advantages for the switching voltage regulator. If you see, there are some disadvantages also, like it is very expensive, because here we are using the switch, we are using the transformer. If you see, it will produce the very noisy output. So these are some disadvantages for the switching voltage regulator. If you see, this is the circuit diagram for step up voltage regulator. Here we are using the inductor, which will increase the output voltage at the output that will be having higher amplitude with respect to the input voltage. So we can say it is as a step up voltage regulator, or we can say it is a boost voltage regulator, because it is giving us higher amount of output voltage. Here we are using the inductor. This is a switch. When switch is closed, at that time it will store the electromagnetic field. It will create the EMF, and this is the diode, and it is a capacitor. We are using here diode to as which can be worked as a rectifier, and it will give us the constant output voltage. And here we are using the capacitors to store the charges at the time of charging phase. If you see step up voltage regulator converter, we can say as a boost voltage regulator, because it will give us higher amount of voltage that will be in higher amount with respect to the input voltage, and the output voltage is regulated as long as power train is in within the output power specification. Remaining part we will see in the next session. Thank you.